Hello, dear all. Welcome to the last session of Chapter 1 in Analytical Chemistry, the solvent extraction. I am Dr. Pratima Matthias, Assistant Professor, Department of Chemistry, IDST Common College, who is going to take you through this session 4. I hope you all now remember from session 3 that we had learned there are different factors which affect solvent extraction. The factors being pH, oxidation state, modifiers, synergism, masking agent, and salting out agent. We have discussed all these factors in session 1. To go through this session, you will have to have a little basic knowledge on what is solvent extraction, what is liquid-liquid extraction, Nernst distribution theory, classification of extraction, and factors affecting extraction. We have covered all these from session 1 to session 3. The learning objective of this session is to analyze the different types of extraction methods, after which you will be able to understand that there are 3 major types of solvent extraction techniques. One is batch extraction, second is continuous extraction, third is countercurrent extraction, and the applications with respect to these extraction methods. What is batch extraction? To say, it is the simplest and most commonly used method. This method is applicable where there is large distribution ratio for the desired separation. Okay, so if the distribution ratio KD is larger, then you can do batch extraction. The solute is extracted from one layer by distributing it with a second immiscible layer in a separating funnel until equilibrium is attained. So this is a distribution method wherein there is large value of distribution ratio. We know that solvent extraction is distribution of the solute particles from one layer into another layer, and it should be immiscible. Okay, this is the same thing, provided one specific criteria is for batch extraction, the distribution ratio should be large. Apparatus for performing a batch extraction is a separatory funnel. Look at this. This is a separatory funnel. It will be of glass with a stopper and a tap here. And you'll have 2 immiscible liquids and the solute particles which can distribute itself between the 2 immiscible liquids. The condition is distribution ratio should be greater in one compared to other. Okay, that is batch extraction. The organic liquid is added to the solution to be extracted in a separating funnel. After agitating for sufficient length of time, the layers are allowed to separate. The tap is opened and the lower layer is allowed to drain. Okay, so the lower layer is allowed to drain through the stopcock, and this is commonly used on a small scale in chemical laboratories. Small scale, even in our laboratories we use this. This is done on a small scale. So the next method is continuous extraction method. Continuous extractions are particularly applicable when the distribution ratio is relatively small. So previous one is when the distribution ratio is large. Here it is when the distribution ratio is relatively small. A continuous flow of immiscible solvent through the solvent to be extracted occurs. This solute is removed continuously with a spent extracting solvent. So this is a continuous process. Okay, the 2 types of extraction apparatus are used depending upon whether the extracting solvent is lighter or heavier than the extracting solution. So if this is lighter, we use one type of apparatus. If it is heavier, because this density is heavier, chloroform and dichloromethane are highly dense compared to benzene, hexane and ether. Okay, so there is a continuous flow of immiscible solvent through the solution. When the extracting solvent is lighter, it moves upwards through the solution, and thus the technique is known as extraction by upward displacement. When the extracting solvent is heavier than the solution extracted, it moves downwards through the solution and is known as extraction by downward displacement. Okay, so the solution is heavier means here you are going to use chloroform and dichloromethane. Here you are going to use benzene and other solvents like hexane or ether. Okay, you will have a particular compound and then you are going to send the solvent or from bottom to top or from top to bottom. This is called as continuous extraction. The solution of the extracting solvent and the solute is continuously separated in a boiling flask. So what has been extracted will be separated in a boiling flask. In both these techniques, the extracting solvent moves through the extracted solution, dissolves and extracted the solute. So what happens is, when you are going to heat this here, okay, when you are going to take this solvent here and you are going to heat it, it is going to pass here. It is going to extract the material and then along with the extractant, it is going to come back here. Okay, it may be this fashion or it may be in the reverse fashion. When it is heavier, it may go from here to here and then it may come back. Okay, when it is lighter, it goes here, dissolves and then it comes back. So these are two methods. These are called as solvent extraction methods. Apparatus for continuous liquid-liquid extraction with the lighter than water extract solvent is to the left. Heavier than water extraction solvent is to the right. So you have both the methods here. The last method is countercurrent extractions. So countercurrent means you're going to pass two immiscible solvents opposite to each other. Okay, countercurrent extraction is a method of multiple liquid-liquid extractions, which permits the separation of substances with different distribution coefficients. Separation of components having variable solubility into immiscible phases, and in this method, two immiscible solvents flow in an opposite direction in multiple stages. This was first introduced by Craig, and the apparatus is also known as Craig apparatus, and it is used for this countercurrent extraction. So this is how the apparatus looks like. Okay, so the separation through continuous countercurrent method is achieved by virtue of the density difference between the fluids in contact. In the previous method, you are passing only one solvent, either light or heavy. Here you are going to pass both light and heavy. So the lighter one moves upwards and the heavier one moves from up to bottom. Okay, in the vertical columns, the denser phase enters the top and flows downwards, while the less dense phase enters the bottom and flows upwards. So Craig apparatus single unit is this. Okay, it is represented like this. It is like this. See, it will be like this. So we have three types we have seen. They are batch extraction, continuous extraction and counter extraction. Coming to the applications, it can be used to the determination of nickel by synergistic extraction, metal extraction using oxime or EDTA or cyanide as masking agents. It can be used for the determination of uranium using oxime in presence of EDTA. Determination of copper as dithiocarbamate. Determination of beryllium as acetyl acetone complex, or determination of lead as dithione complex. It can also be used as determination of molybdenum as thiocyanate complex, nickel as DMG complex, in purification of DNA, in food industry, in isolation of antibiotics, aromatic compounds, or separation of components from plant extracts. To summarize the whole session, we have seen what is batch extraction. In batch extraction, the diffusion coefficient should be higher, larger. When the diffusion coefficient is less or small, then we use continuous extraction. Continuous extraction can be when you use solvents of less density or heavier density, depending upon which you have two types of continuous extraction methods. Counter current extraction means the current which you are passing is counter to each other, which means you are passing uh, immiscible solvents. From bottom to top, you have less denser. From top to bottom, you have heavier. Okay, then we have also seen the applications. Let us look into multiple choice questions. The suitable method of extraction where a large distribution ratio between the two immiscible solvents, which method is that? Yes, it is batch extraction method. A suitable method of extraction where a small distribution ratio is there between two immiscible solvents. Yes, it is countercurrent extraction. Yes, is it countercurrent extraction? Small distribution ratio between two immiscible solvents. Yes, two immiscible solvents. Therefore, it is countercurrent. If it is only one, then it becomes continuous extraction. In which process does the feed and extracting solvent pass through the cascade in the opposite directions? It is countercurrent extraction. Obviously, then this is a wrong option. So for this, it should be continuous extraction. Okay. So the suitable method of extraction where a small distribution ratio is there between two immiscible solvents, that method is continuous extraction. And here, a process in which feed and extracting solvent pass through the cascade in opposite directions, it is countercurrent extraction. So these are few references through which you can go through and use for your further studies. Okay, thank you.